Now chapter 2 moves on from graphing lines to finding the equation of a line. To find the equation of a line, your process is always going to be the same. There's two methods that you can use, and before we can start doing it, what I want to make sure you understand is that there is two forms of an equation. The first one is y equals mx plus b, where m is the slope and b is the y-intercept. This is called slope-intercept form. And then there's standard form. Standard form has your variables on your left and your constant on the right. And standard form they're a little bit more picky about. So y equals mx plus b is great because you can graph from it. It gives you your slope, it gives you your y-intercept. But this standard form is a standard form that you can write any equation in, whether it's a line or a parabola or an ellipse or anything. So the reason they get, because of that, they get picky. So the picky part is that a, b, and c have to be integers, which means there can be no fractions in standard form. The other thing is that the coefficient on x has to be positive. So a has to be greater than 0. So 2x minus 3y equals 5 is great. Negative 2x plus 3y equals negative 5, not so great. So technically right, but not proper. So what's going to happen is that we're going to be finding the equations of lines, and some of you are going to choose a method that always ends up with your answer in the slope-intercept form. But the question may ask you to put your answer in standard form. So before we start finding the equations of lines, I just want to make sure that you can get rid of fractions, really. So if you look at a question like this, the problem with putting it into standard form is that there's a fraction. So to get rid of a fraction, you multiply everything by the lowest common denominator. So these both have denominators of 1. So the lowest common denominator would be 3. So you can either be a creationist and create that denominator 3 and then drop it, or you can multiply every single term by 3. So that you end up with 3 divided by 1 is 3, so you've got 3y. 3 divided by 3 is 1, so you've got equal to 1x. And then 5 times 3 is 15. Then you want to put your variables on one side, your choice. If you put the variables on the right, you'll end up with that positive x term. Or some people just like to say, hey, you know what? I want my variables on the left, so I'm going to do it. So I'm going to go negative x plus 3y equals negative 15. Now this is standard form, but it's not proper standard form. So I'm going to multiply everything by negative 1 so that my coefficient on x is positive. And I get x minus 3y is equal to positive 15. So this is the standard form of this slope-intercept form. So pause the video to give this one a go. In this one, the lowest common denominator is a bit trickier. It's 6. So I'm going to multiply every term by 6. 6 times y is 6y. Here I've got 6 divided by 3 is 2. 2 times negative 1x is negative 2x. I've got 6 divided by 2 is 3, and 5 times 3 is 15. Then I want my variables on the left, so I'm going to add 2x to each side. I'm going to write that x term first, so it goes x, y, equal to my number. And this is the standard form of this slope-intercept form. Okay. Moving on, we are going to now do what we need to do in this chapter, which is to find the equation of a line. To find the equation of a line, you always need two things. You need a point and you need a slope. And then to find the equation of a line, you can use one of the following equations. You can use the slope-intercept equation, or you can actually use the slope equation. So when you're graphing or when you're coming up with the equation of a graph, it's always coming from the most important aspect of that graph. And so the most important aspect of a linear equation or a linear graph is the slope and a point. And so we can find the equation using that idea of a slope and a point. Now really, this is not two different things. Like we're going to call using y equals mx plus b, we're going to call it method 1. And using the slope formula, we're going to call this method 2. But really, there's no difference between the two. It's just sort of how you come up to the answer. But the slope-intercept equation actually comes from the slope formula. If I were to put in a y-intercept as 0b, okay, so let's say I had a y-intercept at 0b, so I put in 0b. If I were to simplify the slope formula using that y-intercept of 0b, I would get m is equal to y minus b over x. Then I'd multiply both sides by x to get rid of my denominator. I end up with mx equals y minus b, and then I would add b to each side, and I end up with y equals mx plus b. So the slope-intercept formula really is the slope formula. It's just condensed to only show the y-intercept instead of 2 points. And so keeping that in mind, you can find the equation of a line using a slope and a point with either using method 1, which is y equals mx plus b, or method 2, which is using the slope formula. It doesn't matter which one you do. My rule of thumb is that you should learn both. Why not? And I use y equals mx plus b when they want my answer in slope-intercept form. And you can use the slope formula if they want the answer in standard form. Or you just stick with one method and you make sure that you can answer in slope-intercept form and in standard form no matter what information they give you. So let's go through and show how these methods work. Method 1, you want to use y equals mx plus b to find the equation of your line. And so we need to find out what m is and what b is. Well, they're giving you m. They're giving you the slope is 1/3, but they're not giving you b. Instead, they're giving you a point, xy. That point, xy, is 3, -1. We're going to use this information to solve for b. So if you've got y equals mx plus b, you're going to put in a y value of -1. You're going to put in your slope as 1/3, and you're going to put in your x as 3. And I've chosen numbers that are going to work out really nicely here, so that my only unknown is b. So I'm going to go 3 divided by 3 is 1. So I get -1 equals 1 plus b. I'm going to isolate b by subtracting 1 from each side, and I get -2 equals b, which means that my equation, y equals mx plus b, I'm going to sub in my slope as 1/3, and I'm going to sub in my b as -2. This is your equation in slope-intercept form. So this method, awesome. Awesome for putting it in slope-intercept form. And if I wanted it in standard form, I really only have to multiply everything by 3. So it's not that bad for standard form either. Method 2 is going to look like more work. But those of you who want a method that doesn't deal with fractions ever, this is going to be your method of choice. Okay, so yes, it looks like it's going to be more work, it looks like more steps, but it's a consistent. This is like the workhorse. So this is the really slow, dependable method of always solving for an equation in standard form or slope-intercept form. Nothing flashy, always the same steps. This one, flashy, right? Super quick and easy, but takes a little bit more work if you want to put it in a different form. So method 2, we do the same thing. They gave us the slope as 1/3, so you put that in for slope. And then what you do is you take one of your points and just call it xy. Drop your subscripts. And then you're going to say, okay, your point xy was 3, -1. So you're going to put in the -1 for y, and you're going to put in the 3 for the x. Now you're going to simplify. So you get 1/3 is equal to y plus 1 over x minus 3. Now this next step is the only one that people ever have troubles with. And they're like, oh, I'm stuck. Well, really what we're going to do, I'm going to call it bottoms up. But really what we're going to do is get rid of our denominators. So if you multiply this side by x minus 3, it goes away. What you do to one side, you do to the other. So I'm going to be left with 1 times x minus 3. This bottom came up. Then I want to get rid of this 3, so I'm going to multiply by 3. And what I do to one side, I'm going to do to the other. So this is going to equal 3 times y plus 1. So this bottom came up. So really your bottoms are going to multiply on the opposite sides. Now you're going to simplify. X minus 3 equals 3y plus 3. Now, if you want it in standard form, put your variables on one side and your number on the other. If you want it in slope-intercept form, just solve for y. So I'm going to subtract 3. I get x minus 6 is equal to 3y. And then I'm going to isolate y by dividing every term by 3. I get 1/3 x, so don't forget there's always a 1 out here, minus 2 is equal to y. So y equals 1/3 x minus 2. So again, workhorse. Looks like it took way more effort, but it's consistent. It's always the same every single time. So now let's look at the next problem. Okay, same thing. Find the equation of a line given a point and a slope. Method 1. Method 1, you're using y equals mx plus b. So if we're using y equals mx plus b, they're going to give me the point. This is x, this is y. So I'm going to say 5, and they're giving me the slope is 1/4, and x is -2 plus b. So then I'm going to simplify. So that's going to simplify to 1/2. So I end up with 5 equals -1/2 plus b. Ugh, fractions. Up to you, you can get rid of them or you can just deal with them. I'm going to add a half, add a half. I get 5 plus a half equals b. I'm going to create a common denominator, so this is going to be 10 over 2, so I multiplied by 1, but I multiplied by 2 over 2, plus 1/2 equals b, and I get b equals 11 halves. So my equation would be y equals, my slope is 1/4 x plus 11 halves. Great, except they want it in standard form. So now I'm going to multiply everything by 4. So you pick the lowest common denominator, and then you clear it. So you get 4y is equal to, 4 divided by 4 is 1, so I get 1x, 4 divided by 2 is 2, and I get plus 22. And then I'm going to move the x over. I get -x plus 4y equals 22. And then I'm going to do times everything by -1, so I get that positive a value. And I get x minus 4y is equal to -22. So a little bit clunkier, right? Looked like magic in the first example. Looked like the best possible method ever. And in this one, felt a little bit clunkier, but doable. Method 2 is using that good old workhorse, the slope formula. So again, we're going to plug in the slope is 1/4. We've got x and y, and we're going to plug in our point. So -5, and then take away -2. Then I'm going to simplify, so I get 1/4 equals y minus 5 over x plus 2. And then here's that tricky spot, bottoms up. So I'm going to go x plus 2 times 1, because I'm multiplying both sides by x plus 2. And then I'm going to multiply this side by 4, because really I'm multiplying both sides by 4, it goes away. Then I simplify. X plus 2 equals 4y minus 20. And then my variables go on the left. So I get x minus 4y plus 2 equals -20. And then I'm going to subtract 2. And I get x minus 4y equals -22. So again, same steps. So method 2 is really consistent. You plug in your slope, you plug in your point, you always bring bottoms up, you multiply through, and then you either isolate for y or you put your variables one side, kind of depending on what they want the answer in. Method 1 looks flashy, looks super easy and great with number 1, gets a little bit clunky with number 2. So if you're looking for like the workhorse, dependable method, just choose method 2. If you like method 1 and you just want to stick with one method because it's what you did in Math 49, feel free to do that. Some people come up with the theory that they really like using method 1 when they want the answer in slope-intercept form, and then they want method 2 when the answer has to be in standard form. It's totally up to you and sort of what you get comfortable with. All right, so go to your homework and do the questions that say find the equation of a line given a point and a slope, and then come back and we will build on this.